Welcome to Module 2 for the specific equipment training for ISO1 East Dryer. We will now go through the component identification. Again, the purpose of the component identification is to allow us to understand the system, to identify the individual components that all play a key role in the sequence of operation, which is the ultimate destination for our training session, and to help us to have the clearest understanding of the process and the controls that are involved. One more time also, as we had explained earlier, we will be using technical terminology for the components and the items that we're reviewing because this is the universal language, no matter what country, no matter what city, no matter what process, that speaks universally to anybody who arrives at our site. It's okay to come up with nicknames and a little bit of slang as we go forward, but the training has its best effects when we learn the technical side. Okay, let us begin. So burner safety components, again, remembering that safety is number one for ADM at any facility. We would like to go through the component identification for the burner system. So the first item we're looking at is a dung pressure switch. That's the manufacturer's name. So you can clearly see that. And it's used to stop the burner. If natural gas pressure is too low, there is a second switch that is used to stop the burner if the natural gas pressure is too high. So these are intricate safety features, and we would wonder, why would the gas pressure rise too high? Why could it rise or drop too low? The too high can come because we had a failure of a regulator that's stepping down the incoming pressure. As you recall, we had shown some regulators, and we'll get that detail reinforced later. The next item is an airflow switch, and that is used to prove that fans are running and to prove that air is flowing at designated parts of the process system. The key to this explanation is the word prove. We're not validating something, we're not verifying something. These are intricate into the logic of the system, and we have proof positive that these functional features are active. Very, very important. Continuing, we have high temperature cutout, and that's the picture of what we see. This device is located in the MCC, Motor Control Center, and it is on the panel doors. This device will monitor the drying temperature, and if it gets too high, the natural gas is stopped and the dryer will stop. Again, very good safety. And one that we're very familiar with from other processes, the bottom picture, is an e-stop or emergency stop switch. By pushing this switch, the natural gas is stopped and the dryer will stop. And we'll show how that happens functionally a little bit later. The next component is a Maxon, and that's the manufacturer's name. So it's a Maxon blocking valve. It's used to block the flow of natural gas to the main burner when the dryer is not in operation. That could be because we have shut it down through a methodical process, or it could be because there has been a safety issue, and these are the valves that will cause the flow of natural gas to cease. The bottom is showing the natural gas pressure regulators. They are used to reduce the natural gas main supply line pressure to the pressure required to the burners. And we had briefly touched upon that earlier, mentioning that our incoming pressures would be somewhere slightly below 10 psi, and we're sending between 1 and 2 psi to the pilot and to the main burner. And again, if something happened with one of these, that could be a source of high gas pressure, which would be sensed through the safety features and shut the system down. Modulation motor. This regulates the amount of natural gas sent to the main burner. Now we're getting into the control aspects of the burner. And there's two main elements. The first is the Honeywell relay module. And you can see by looking at the picture, we call it a burner control. The technical name is relay module because it functions as a relay. So it opens and closes things to cause the sequence of operations such as purge to begin. So it controls startup functions such as the purge, pilot ignition, and main burner ignition. It communicates with the expanded annunciator for any safety problems. So looking at the bottom picture, the Honeywell expanded annunciator, and we can see that's the label that we have on there, and we see multiple red LEDs or LEDs that are lit, showing the color red. And this indicates proof of closure and constantly monitors the series limit stream safeties for problems. So very integral in itself. It is a neutral piece of equipment, but it brings these signals in from our various safety components, and if there's any problems, it will be the instrument that allows us to shut the burner down automatically. A little bit more familiar for some people is the flame rod. It produces a spark to ignite the natural gas to the burner pilot, and that is done through the bottom element, the high voltage ignition transformer. This provides the high voltage to the flame rod to ignite the natural gas for the burner pilot. So the high voltage ignition transformer, very critical, so it draws a very high voltage but extremely low amperage so that we can draw the required spark. We don't need a lot of flow, we just need that spark to ignite the natural gas. A very critical element, the flame detector. In this one, we move a little bit away from the technical terminology because it's very common to call it a scanner. So the technical name of it is, it's a Honeywell dynamic self-check ultraviolet flame detector, and it has the model number. What it's actually doing is it's looking for ultraviolet source of the flame, whether it's the pilot or the main burner. Then we have our temperature sensors. They monitor temperature, provide feedback for the operators to the graphical user interface and to the system through the PLC for proper control through it, because it is a PID system. Then we have RTDs, which are temperature sensors. They monitor temperature, provide feedback to our control system, which is the PLC, and for feedback to the graphical user interface. As we have an example here to the lower right. So what these sensors, where they are showing, is inside those circles. So we can see the functionality of them as well as giving the feedback. A proper identification of each one of these sensors, physical proper identification, will be very critical for the troubleshooting and maintaining of the system. That concludes module number 2, and we'll be prepared to start module number 3.